Hello, we'll be starting covalent bond or molecular bond today. What is covalent bond? The chemical bond that is formed between two combining atoms by mutual sharing of one or more pairs of electrons is called a covalent or a molecular bond. And the compound formed due to this bond is called the covalent compound. Now, so here there is a sharing of electrons and this molecule is called covalent molecule. Now, who are forming covalent molecule? Those which are having 5, 6 or 7 electrons in their outermost shell, and these are non-metals, you already know. Except carbon. Carbon is having 4 electrons in its valence shell, and hydrogen. Hydrogen is having 1 electron in the valence shell. These atoms, they form the covalent molecule. Why? Because these atoms do not favor loss of electrons due to energy consideration. So, they do not allow transfer of electrons like it happened in electrovalent or ionic bond. So, these atoms can complete their octet only by mutual sharing of one or more pair of electrons. This is very important part. So each atom contributes equal number of electrons. So whenever a non-metal combines with another non-metal to attain stable configuration of nearest noble gas, the sharing of electrons take place between their atoms and covalent bond is formed. Now, what is the example? If you take the example of hydrogen chloride or hydrochloric acid, here hydrogen is a non-metal, chlorine is also a non-metal, and here the sharing of electrons takes place between hydrogen and chlorine and covalent bond is formed. We will discuss the detail in soon. Now, covalent bond is formed between two atoms of same non-metal. Like examples are formation of chlorine, oxygen, nitrogen, etc. Now there are three types of covalent bond. One is single, where there is a sharing of one pair of electrons between the atoms and each atom will contribute one electron. There is a double covalent bond which is formed by sharing two pairs of electrons. So each atom will provide one pair of electrons, that is 2 electrons. So 2 electron is equal to 1 pair. So 2 atoms will give 2 pairs. Triple bond is formed by sharing 3 pairs of electrons. So each atom will give 3 electrons. Now examples of single covalent. First one is chlorine, then HCl, then NH3, that is ammonia, then methane, then water, then CCl4. We will discuss the formation of some of this in due course of time. Now, what about the double covalent bond? Double covalent bond is the combination of two single bonds, which is represented by putting these two short lines. It is shown over here. Between two atoms. So, oxygen is your having double covalent bond, which you generally say double bond. Then third one and last one, that is triple covalent bond. Here you have 3 single bond, combination of 3 single bonds. So example, which you normally say triple bond. So N triple bond N, that is nitrogen molecule. Formation of nitrogen molecule is an example of having triple bond between the atoms. Now there are some molecules which are having combination of single as well as double bond. So you have single and double bond, or you may have triple bond also. So both will be present, single as well as double, or single and triple. Now let us see the example. Let's say the example of ethene molecule. What is ethene? Details are there in class 10. It has one double covalent bond and four single. It has one double covalent bond and four single covalent bond. And four single bonds. I am not telling the covalent every time. So the example you see, C, carbon is having 4 electron in its outermost shell. This you know. So now these are 4 electrons of carbon. Here you are having 1 electron of hydrogen. So you have to show carbon electrons are shown by this dot and hydrogen electrons are shown by cross. So now these two will form pair, these two will form pair. So you get double bond. So you get C double bond C. 2 electrons form a bond. Now here then you have these 2 electrons form a pair. So you get this bond. These 2 electrons form a pair. So you get this bond. Then you have here these 2 electrons form a bond. So you get this. And these 2 electrons form a bond this. Now here carbon is attaining the nearest noble gas structure. Now carbon is having how many electrons? Total 6, 2, 4 electronic configuration. So what is the nearest noble gas of carbon? That is neon, that is 2, 8. So carbon is attaining nearest noble gas structure. If you see the total number of electrons over here, you will find it is 10. Now what about hydrogen? Nearest noble gas of hydrogen is helium. Helium has 2 electrons in its outermost shell. So hydrogen is having, you see these red parts, hydrogen is having 2 electrons. So you finally find this is the structure of combination of single and double bond. This is for ethene, which is commonly known as ethylene. Now we will do for single and triple bond. So example is ethyne. Okay, so you have the structure of ethyne as, in this case you will do like carbon, three electrons here and 1 electron here. There are 2 hydrogens. You have to satisfy the valency of carbon also. Carbon has 4 valency because it requires 4 electrons to complete the octet. Now you can see the pairs over here. 3 bonds. 1, 2, 3. And here 1, 1. So it has 1 triple bond and 2 single bond. So 1 triple bond and 2 single bonds. So you get the structure like this. So there is a term called covalency. There is a term called covalency. What is this? This is the number of electron of an atom which takes part in the formation of sharing of electrons. So number of electrons of an atom taking part in the sharing of electron. In previous cases you have seen for hydrogen only one electron is taking part, hydrogen 1. Oxygen you have seen 2 electrons take part. In nitrogen you have seen that 3 electrons take part. In case of carbon 4 electrons take part in the bond formation. So covalency of hydrogen is 1, oxygen is 2, nitrogen is 3 and carbon is 4. Then we'll move towards the formation of hydrogen molecule. So how hydrogen molecule is formed? Hydrogen is having only one electron in its valence shell. So it will need one more electron to attain the duplet. So what is this duplet? Duplet is the structure of or configuration of helium. So hydrogen atom shares its electrons with another hydrogen atom. So one electron each is contributed by the two atoms of hydrogen, and this resulting pair of electron is mutually shared by both the atoms to form hydrogen molecule. So this is one hydrogen atom, this is another hydrogen atom, you get hydrogen molecule. Now if you see the electron dot structure, this is shown by this hydrogen atom with this electron, and this is the after combination. How do you draw this? First you draw these two circles, write hydrogen over here and put these two electrons here. So this is your sharing zone. You can show by this is orbital structure. This is actually orbital structure. This is electron dot structure. This is also electron dot structure. Or you can write this way. Fine. Next is the formation of chlorine molecule. Now you can see chlorine has electronic configuration of 287. Nearest noble gas is argon. So its configuration is 288. Now to get the stable configuration of argon, chlorine needs only one electron. Okay, so when two chlorine atoms are produced, you see there are 7 electrons. 2, 2, 2, 6, and this is 1. So each chlorine is sharing one electron, so they are having single bond. You see this is the electron dot structure, and here again you draw this. First you draw the circles, make the sharing zone, put your electrons over here, then put chlorine and write all the other remaining electrons this side. Okay, so this way you can draw chlorine. So similarly I have shown you how to draw this structure in the previous one. So practice this regularly. Then you have oxygen. How to do this oxygen molecule? Oxygen is having electronic configuration 2,6. Nearest noble gas is neon. Neon is 2,8. Now to attain the stable configuration of the nearest gas neon, oxygen needs 2 electrons. When 2 oxygen atoms come closer, each contributes 2 electrons, so they have 2 shared pairs of electrons. So you see here 2, 3, 4 and 5, 6. So this way you will place the electrons. After combination there is a sharing, so you can have 2 bonds. So now you have two bonds, one bond and two bond. So you will have double bond. So how to do this? You draw this, put two oxygen electron here, 3, 4, 5, 6. Similarly, this oxygen also, 1, 2, 3, 4, 5, 6. Make the bond pairs. So you get O double bond O. That is O2. Next you have, now there are certain other words are mentioned over here, that is non-polar molecule, etc. So we'll be doing polar and non-polar molecule. Similarly, you can do this for nitrogen. Nitrogen is having 3 electrons are required to get attain the stable configuration of the nearest noble gas, that is neon. So it requires 3 electrons. So you can make the formation of nitrogen molecule the way I have shown you. Now this is a polar compound. Now we will go for what is polar and non-polar. There are two more types of covalent compound. One is polar, another is non-polar. Now if you see, covalent compounds are non-polar when shared pair of electrons are equally distributed between two atoms. Now if you see nitrogen, here shared pair of electrons are equally distributed because though both the atoms are same. In case of nitrogen, shared pair of electrons are equally distributed. Okay, so these are non-polar. So there is no charge separation is taking place. If there is if the shared pairs of electrons are not equally distributed, there will be charge separation. Means one will be attaining positive, another will be attaining negative. But here these molecules are symmetrical. And neutral. But if two, so this is one example like nitrogen. Other examples are whatever we have done till now, that is oxygen, then chlorine, then hydrogen. So these all are non-polar compound. Now here in case of hydrogen chloride, you can see the covalently bonded atoms. These are identical. The shared pair of electrons are at equal distance, that you have seen. So these are equally attracted by the nucleus. Now if there is two different types of combining atoms, like here it is hydrogen and chlorine, here hydrogen shares the electron pair with chlorine atom, but there is no equal attraction by the nuclei, because chlorine has the capacity of attracting electrons towards it. So the shared pair of electrons between hydrogen and chlorine are not at equal distance between the two positive ions. These will be towards chlorine. This will be towards chlorine. These are not at equal distance between two atoms. Those will be little bit attracted by chlorine. So there is a development of fractional positive and fractional negative charge. Fractional positive, this is the bond formation between chlorine and hydrogen. You draw remaining, this is for hydrogen and chlorine. This will be little bit attracted towards chlorine, both the electrons. So there is a fractional positive and negative charge on them, and they ionize in water. You can see the formation of chlorine over here, hydrogen chloride over here. Next, covalent bond is formed when both the combining atoms have 4 or more electrons in their outermost shells, that is non-metals, exceptions hydrogen, beryllium and boron. And hydrogen can combine with all non-metals with the help of covalent bonds. So that's why there are huge compounds of hydrogen also. So this is why this is a polar compound, this I have told. Now in case of ammonia also, now this is the case of water first, we'll be doing water first. In case of water, you see oxygen, there is a hydrogen is having 1 electron, oxygen is having 6 electrons in its outermost shell. So 1 electron of hydrogen, so they are forming now bond. Okay, so you are getting this type of bond ultimately. Now what is happening? Oxygen is also, here it is written polar compound. Water is also a polar compound. Why? Oxygen is again having the capacity to attract electron towards it. We will be discussing this part in the periodic table section, why it is attracting electron towards it. So once oxygen is attracting electron towards it, so oxygen will be having little bit negative charge and hydrogens will be having positive charge, as if there is a charge separation and formation of 2 poles. So that's why it is called polar. What are the 2 poles? One is positive pole, another is negative pole. So that's why it is called polar. Similar for ammonia. In this you will see nitrogen is having capacity of attracting electron towards it. So here nitrogen will be having little negative and remaining will be little positive. So nitrogen is having capacity of pulling electron towards it. So there is a generation of 2 poles, one is positive, another is negative. So this is again a polar compound. Now if you go for the carbon tetrachloride, it is not polar. Carbon tetrachloride and later on we'll be doing methane. These are not polar. You can see here carbon is having 4 electrons in its outermost shell. Chlorine is having 7 electrons. So carbon requires 4 electrons to complete its octet. So you require 4 chlorine. So carbon will make bond with 4 chlorine atoms to complete its octet. Then you have methane. So carbon tetrachloride was a non-polar compound. Methane is also a non-polar compound. Here again carbon is having configuration 2,4 attaining the neon configuration, and hydrogen will have to attain helium configuration. So there are similar formation of CH4. So covalent compounds are molecules with weak molecular force of attraction. So they are either liquid, gases, now covalent compounds are molecules with weak molecular force of attraction. So they either are liquid, gases or soft solids. These are volatile compounds having low boiling or melting points, non-conductors of electricity in solid, molten or fused or aqueous state, insoluble in water but dissolve in organic solvents. If you pass electric current, non-polar covalent compounds do not ionize. That is, there is no formation of ion, like example of carbon tetrachloride. But if you have the polar compounds and if you pass electricity through it, it forms ions and ionize in their solutions, and these are called electrolytes. Remember this word electrolyte, which is HCl is the example. Thank you for patience hearing. Thank you.